Uses of electrolysis. Going to look at 3 uses of electrolysis. First one is extraction of aluminium. The second one is purification of copper. The third one is products from the electrolysis of brine. So extraction of aluminium. Have a look at the cell drawing. So we have a tank. And the lining of the tank is actually the cathode. So that's there with a negative charge. So this is the tank itself. Okay, so this here is the cathode. Across here to remind us as well. And then you have some carbon anodes which dip down into the electrolyte. Carbon anodes. And then we have our raw material, which is aluminium oxide, and it's dissolved in molten cryolite. Which lowers the melting point. Which means that less energy is used in this electrolysis. Okay, so inside our cell we have aluminium oxide, which is the electrolyte. And this is an ore, an oxide ore, and that consists of 2 ions, the Al3 plus ion and the oxide ion O2 minus. So the equation at the cathode, Al3 plus goes to the cathode, picks up 3 electrons to make aluminium. Because everything's molten, this is going to come off as a liquid. The anode is a bit more complicated. Here we have our oxide ions, and they're going to travel to the anode, where they're going to lose their electrons to make oxygen gas. So here's our oxygen gas O2. We need to balance this. 2 O2 minus goes to give O2, and then we're going to have 2 times 2 minus here, which means we need 4 electrons on this side. This isn't the end of the story, however, because the anodes are made of carbon, and this is taking place at a high temperature. So the anodes will react with the oxygen produced. C plus O2 going to give CO2, which means that over time the anodes will wear down. And they will need replacing. Purification of copper. So if we have a tank here, we're going to have 2 electrodes in there. This is our anode, this is our cathode. Each of these is made of copper, however the cathode is made of pure copper. And the anode is made of impure copper. Here you've got an electrolyte, most often it's copper sulfate solution. Okay, so what's happening at both of these things when we switch on the electricity? At the anode, you have the atoms of copper will leave the surface of the copper as ions. And then they will travel to the cathode. Here you get cathode Cu2 plus 2 electrons going to give Cu. And since only the copper can travel through the solution, any impurities are left behind. So if this is the before picture, and this is the after picture, so our cathode will have got much bigger. It's gained mass. And our anode should have got smaller. And any impurities that have come off at once the copper has been travelling through the solution will be left on the bottom here, and we call this anode sludge. Electrolysis of brine. So brine is a solution of sodium chloride. So that's sodium positive ion and chloride 1 minus ion. So we'll deal with what happens at the anode first. At the anode, yet the Cl minus ions travel to the anode. Here they give up their electrons and combine to give chlorine gas. Remember, that's diatomic, Cl2. We need 2 Cl minuses, and 2 times 1 minus means we have 2 electrons here on this side. Chlorine gas is very useful. It's used in the manufacture of bleach. Now at the cathode, sodium is more reactive than hydrogen. so sodium will not be discharged. Instead, hydrogen ions are discharged from the water. So here is our water, H2O, and that breaks up to give hydroxide ions and H+ ions. Now hydroxide ions stay in solution and they combine with Na+, to give sodium hydroxide, which is a useful chemical. And then also the equation for what happens at the cathode, you have H+, travels to the cathode, picks up electrons to make hydrogen gas, balance the atoms and balance the charges. Hydrogen gas is also very useful. It can be used as a fuel, can be used in the production of things like margarine.